Ladies and gentlemen, welcome to another episode of Cosmic Catastrophe, exclusively on Rumble, Saturday, 8 p.m. Mountain Time, with a replay Wednesday over on YouTube at Magnetic Reversal News. We got a great show. I'm your host, Diamond, and joining us is my lovely partner and co-host, Leah Shaper.
Hello.
Welcome to the show. We're going to be discussing three topics today. We're going to rehash something we discussed maybe a few years ago, a paper coming out about a population bottleneck around 1 million years ago. And according to AI, our population could have been reduced to as low as 1,280 survivors. But who knows? We'll talk about that. And we'll also go over some things happening at the same time geologically that may explain what AI discovered there. The second topic is a new paper coming out, the discovery of an invisible threat. This is a swarm of hidden city killer asteroids that are co-rotating with Venus. And so we're going to get into that because they may be a problem for Earth, potentially. And then finally, we'll talk about the Younger Dryas catastrophe. A new paper coming out from the Comet Research Group shows evidence of a 12,800-year-old shallow airburst explosion in Louisiana, which would be just more evidence that 12,800 years ago, bad things were happening on Earth.
Mm-hmm.
So do you have any... I
have no opening thoughts.
Yeah. No opening thoughts?
No, not right now.
Okay. Let me present the screen. I can't even find the page.
Uh-oh.
It's here. It's just out of order.
Too many tabs.
All right. Can you see it?
Yeah.
Only 1,280 survived. The near extinction event that nearly wiped out humanity 1 million years ago. So according to this article in Science, a dramatic event nearly wiped out humanity 1 million years ago, according to new genetic research. Now, the new study reveals that our ancestors may have been reduced to just 1,280 individuals, leaving the human race on the brink of extinction. This dramatic event, known as a genetic bottleneck, lasted for 100,000 years. The study published in the Journal of Science provides a sobering look into a critical moment in history by analyzing genetic data from 3,154 modern humans, including individuals from both Africa and non-African populations. Scientists uncovered evidence of a massive population decline, and this decline occurred between 930,000 years ago and 813,000 years ago. And it says here the human population dropped by an overwhelming 98.7%, reducing it to a mere 1,280 reproductive individuals. Holy macaroni. The bottleneck lasted for 117,000 years. This is very crucial. This time period, the time frame when we start to look at some of the graphs.
Mm-hmm.
So what are your thoughts on the study?
Unfortunately, I did not get a chance to go back and review the study. So I think we covered this 2 years ago. I have questions because it's only a sampling of 3,000 and change people, which isn't really very much. I vaguely recall that the sample was a little lopsided, right? They say Africans and non-Africans. Actually, I think it's now that I'm thinking about it, I think I felt it was lopsided before, simply because you're lumping all non-Africans together, which doesn't really make sense, right? Like, clearly Caucasians and Asians have different geographical origins. So when you lump all of those together, so even if you use half African and half non-African, that's kind of strange to do it that way.
Yeah, I would think you would take an equal number of like all races.
Right. That would make more sense. However, what is interesting is that one of the crucial pieces, it's funny, I'm only looking at your screen, but in my head it's on my screen, so I keep trying to scroll down the article.
Oh,
Um, but what is interesting is that what came out of this is that two chromosomes that were previously separate prior to this time became one chromosome, is what they're saying. And so that separated us from the apes by reducing our chromosome number to 23 from 24. So, I mean, it is kind of interesting that you have this chromosome unification that happened. I mean, obviously, that would be a major change in the evolution of all hominids.
well,
but-
let's take a look at this time period.
Yeah.
Here we have the last 4 million years. Current is on the left side of the graph where Homo sapiens are.
Mhm.
And the event occurs right around 1 million. There is very little fossils. There are almost no fossils between 1 million and 800,000 years ago.
Yeah.
The only fossils we have are of Homo erectus and more recently Homo naledi. And so those are the only two Homo species around during a very long period of time, which lasts from around 1.6 million years ago to about 800,000 years ago. That's about 1 million years where there's only two hominids on Earth.
Yeah.
Now, the question is why? And we've talked about this graph before. 5 million years of climate change. You remember this graph, right?
Of course.
So the ice age that we're currently in began 2.5 million years ago when we went below this hypothetical dotted line.
Mm-hmm.
And somewhere around 1.2 million years ago, we went from a 41,000 year cycle to a 100,000 year cycle. And so I found a higher resolution of that time frame. And you could see the present is on the right of this graph. Do you see the new graph?
Yeah.
Okay. So if we go back between 900,000 and 800,000 years is this huge, very unique down, continuously cold period.
Yes.
And so that is the time frame when this is happening.
Yeah. And the this is also when the frequency is changing.
It's also the flexure point of the frequency right there.
And the maximums are higher and the minimums are lower, so it's more extreme.
And what go ahead.
Well, the other thing that really strikes me, if you go back to the graph of the hominids, is that, prior to Homo erectus, we have, at 2 million years, we have very roughly, we have a huge variety of hominids.
Oh, yeah.
And then we have two. So I don't doubt that there was a genetic bottleneck. Are the numbers in the paper correct? I have questions about that. But it seems pretty clear that there is a genetic bottleneck and it's linked to changes on Earth.
And a very deep 100,000 year glacial maximum.
Yeah.
So it's very difficult to live on Earth that time. Now, let me blow your mind. I pulled up the paleomagnetic data. And so the last magnetic reversal was 780,000 years ago. And prior to that, it was 900,000 years ago. So the beginning of this bottleneck coincides with a magnetic reversal, and the entire length of it is for the entire length of the reversal.
Yeah.
That's pretty interesting.
Yeah, that is extremely interesting.
And but it's very low correlation, because that time frame you were talking about for 2 million years when we had all those hominids, there were multiple magnetic reversals. 1, 2, 3, 4, 5, 6. See that? And a lot of them were abrupt. Look at these thin black lines. Isn't that crazy?
Yeah. Well, but they're abrupt but shorter.
Yeah.
Right, which is going to have an impact on survival.
So it's hard to blame just that one magnetic reversal had something to do with this.
No, and I think that the climactic change that we're seeing in the data, would also be playing a role, because that climactic change is enormous.
Right. And whatever the control mechanism that changes us Let's go here. From a 41 kiloyear cycle to a 100,000 year cycle, whatever that mechanism is, that's happening at this flexure point.
Yeah. Yeah. So what the heck is that, right? We still have no idea what that is. It has to be something on a grand scale, on the scale of the solar system or larger. If it's on the scale of the solar system, then it has to be caused by something outside the solar system.
Right, but it matches perfectly with the Milankovitch orbital cycles, right? So prior to the flexure, it matches the obliquity cycle of 41 kiloyears, and then after it matches the eccentricity cycle of 100 kiloyears. So who flipped the switch?
Right.
And or is it just a coincidence that these time frames exist and they don't have anything to do with the Milankovitch orbital perturbations? Like there's no way to check.
No, all we have is correlation, right? We don't have causation, so all we have is correlation. The correlation are clues that lead us in the right direction. But another thing that strikes me too is, we don't really know, all of the various hominids at 2 million years. We don't know what their intellectual capacities were, right? And we discussed a couple of shows ago about how, one of the impacts of a magnetic excursion or reversal, all of that extra radiation would be things like utilization of folates in the body, which would have a huge impact on the health of newborn babies, right? Things like that could have huge impacts on ability to survive. So if your ability to survive is being impacted in a great way by all of the extra radiation during a reversal or an excursion, and you don't have the capacity to make the connection to like go live in a cave to protect yourself from that during the day, then you're not likely going to make it. Now, I'm not suggesting necessarily that the intellectual capacity of these hominids was low, because we do not know. There's no way to know that. But
no, and for sure, what we do know is the cranial capacity of Neanderthal was greater than ours. So
right. Yeah.
And I see some pretty big skulls here, like Homo rudolfensis looks like a pretty large skull.
Right.
As well as Eragaster, Homo eragaster has a very large cranium. And
well, that also
2 million.
relies on what I consider to be kind of an assumption that cranial size has something to do with intelligence. It probably has something to do with it, but it's probably not everything. Because it's not true within a species, right? Like within Homo sapiens today, there are people who have larger heads than others, and they're not more intelligent than people with smaller heads.
No, but microcephaly, definitely you have very low IQ if you have no brain capacity.
Sure.
All right. So and just for those watching, this list of hominids is highly limited. There's probably,
it's only what we've ever found.
Yeah, there's probably at least 5 times more than this.
Right.
I mean, we recently discovered Homo floresiensis and many other things. They're not even on here. Like Denisovans aren't on here. Floresiensis isn't on here. So there's a lot more bipedal hominids running around the last few million years.
This is a funny thing about anthropology that's always bugged me, right? Is that there have always been anthropologists that develop theories based on the fossils we have without recognizing that there could be a million missing pieces that we're not aware of. And I always find that funny. I mean, I understand that it's, tempting to theorize based on the evidence you have, even if it is obvious that it's limited, but
you do your best.
Right.
That's it.
Yeah.
All right. Anything about the population bottleneck you think we missed?
Well, I mean, we've been talking about this quite a bit, but we've been talking again and again and again about the possibility that whenever there is a large-scale natural catastrophe on Earth, that this causes isolation of hominids, which could then further create genetic differentiation between populations. Populations that are isolated now have a limited genetic pool from which to draw. And so it could, in that respect, it could very well be a lot like, breeding dogs, where you breed dogs for specific characteristics and you have a more limited gene pool, and then you end up with a dog that has a very specific appearance. and we've been saying again and again recently that, especially considering that, for example, Homo sapiens and I can't even say it, that Neanderthals, I'll just say it that way, interbred, then perhaps they really were the same species that were highly differentiated based on geographical isolation at some point prior to them coming together again. Your mic is off.
I bet you Heidelbergensis and Neanderthalensis were also interbreeding.
Sure. Why not?
Yeah.
As long as they were in geographical proximity to each other. I mean, I've postulated that, Homo floresiensis, that we interbred with Homo floresiensis as well. And maybe that's the reason why we have dwarfism. Maybe not, but.
Yeah. And so what's happening here is a regular major climatic disaster, a cyclic disaster happening every 100,000 years for the last million years. And then prior to that, the disaster was happening every 41,000 years.
Right.
So every 41,000 years, all the populations that exist on Earth kind of come to a halt. There's very little migration. Times are tough. You got to hunker down. And then it gets really nice out and people can migrate and move around and intermingle.
Mm-hmm.
And this just happens again and again and again.
Right. And you can imagine too that especially if, especially during an excursion or a reversal, that would really limit migration because you don't want to be out during the day, which would cause you to travel at night, which may present other dangers as far as animals go, and your ability to see. Your senses are limited at night. So
yeah, bears feed at night. So
yeah.
And back then there were some big bears.
Right.
All right. How about we switch the topic?
Sure.
An invisible threat, a swarm of hidden city killer asteroids around Venus could one day collide with Earth, simulations show. Okay. According to the paper, currently 20 co-orbital asteroids of Venus are known. For those of you that don't know what a co-orbital asteroid is, it's simply an asteroid that is in the same orbital range as Venus is.
Mm-hmm.
That makes sense, correct?
Yes. As distinguished from, it's not orbiting around Venus per se.
No, it's orbiting around the sun.
Right.
It's as if Venus is pulling them in its tail. And according to this semi-analytical model of the motion, simulations to monitor close encounters with Earth on several co-orbital cycles, they analyze observability windows and brightness variations for potential Venus co-orbitals as viewed from ground-based telescopes. Okay, so that's just all we have is the abstract.
Oh, I have the paper.
Oh, okay. How did you get the paper?
There was a link in the article, and it came right up.
Yeah, I just got the abstract from that.
Huh, interesting. I was able to download it and everything.
Well, aren't you special? So, so what is the threat, and is it likely?
Well, I mean, here's this will give some perspective on that. So they observe 20 of these co-orbital asteroids. They fully acknowledge that there may be more because they're limited in what they can see because of the glare from the sun. But an important statement here is co-orbital status protects these asteroids from close approaches to Venus, but it does not protect them from encountering Earth. I'm just going to read from the paper here for a minute. A potentially hazardous asteroid, a PHA, must have a minimum diameter of about 140 meters and come within 0.05 astronomical units of Earth's orbit. The maximum absolute magnitude for an asteroid to be classified as a PHA is typically around 22. I don't actually know what that maximum absolute magnitude means. Karuba and others, there's another paper that was written about this year, identified 6 co-orbital asteroids that can become PHAs in the next 12,000 years. So those are pretty good odds. with 3 of those having a minimum orbital intersection distance, which is the distance between the closest points of 2 objects' orbits, with Earth of less than 0.0005 AU. So
That's low.
well within the parameters of impact.
So
Oh, and
these,
also the diameters of those 3 asteroids are 330 meters, 300 meters, and 390 meters. So again, well meeting the criterion.
yeah,
Of,
and that's all for those who don't know the metric system. That's 1,000 foot across.
right.
That's huge.
Which, we're also talking about asteroids that are capable of taking out a large city.
Yeah, 3 football fields across.
Right. It's funny because somewhere in here also they say that that it would cause localized damage and destroy a whole city, but and potentially cause a tsunami if it was near the coast. But I think that's really an understatement. If you can destroy in a large city with an object, then that means that there are many other consequences that are going to come out of that, as far as, let's say, particulates entering the atmosphere, etc.
Oh, yeah.
It's not going to just affect a large city. It's not going to be that localized.
It's going to affect the whole planet.
Right.
So these are not really co-orbital. They have to have huge parabolic trajectories, where most of the orbit is in Venus's orbit, right? But it's the back end of the parabola that comes near Earth's orbit.
Yeah.
So they're oblate, and they're going. See, that's so weird. So they're going around the sun using Venus's orbit and coming really wide close to Earth's orbit on the back end.
Yeah. Which is why they're more of a threat to us than they are to Venus.
Right. And so we go around every year, right? So you have to meet one of those objects at the perfect time on the back end of the orbit as we're moving by.
Mm-hmm. And it's well, it's kind of interesting too that they used the figure in the next 12,000 years, right? It's half the precessional cycle. So that makes sense, because that's how you would determine the frequency with which we would encounter this orbit, right? You would sort of judge it by that.
Huh. Interesting.
Yeah.
Don't be scared. Be prepared, because when it happens, there's nothing you can do.
No, definitely not.
Especially if you're at ground zero and you get hit.
Yeah.
You won't even know.
Well, so the other thing that's kind of interesting about this, and okay, granted, and I didn't even really realize this, but there are other planets that have coorbital asteroids, including Earth.
Yeah.
But the impression I got is that the number of coorbital asteroids with Venus is a lot. And it immediately made me think about the idea of Venus having once been a comet, and perhaps these asteroids are part of its debris field. But since other planets also have
or they could have been captured as it was moving through the solar system.
Well, yes, right. I mean, the supposition in this paper is that these come from the asteroid belt. But why, and how did they get there? Like, what triggered them to get there is the question,
Yeah.
So
I'm going to blow your mind here. Oh,
yeah.
What's happening? Why didn't that just happen?
What? Trying to switch your screen?
Yeah. Do you see this?
Yeah. Yep.
That is Mercury.
What is?
The comet that you're looking at is not a comet. It is the planet Mercury.
No way.
And so Venus has a similar tail.
Yeah.
And you can also see the Pleiades there right above it.
Yeah.
Yeah. So long exposure astrophotography reveals that Mercury and Venus, the inner planets, certainly resemble comets now, don't they?
Well, I mean, this shouldn't really be that surprising, right? If it is indeed true that the entire universe is electric, which I thoroughly believe, then all planets have a charge, and that charge is going to be drawn in a particular direction based on the dynamics with other bodies that are also electrically charged. So it's not really that surprising. It's very cool, because
Yeah.
it's evidence of electric universe, in my opinion. And it again brings home the idea that perhaps there is less difference between a comet and a planet than we previously thought, as
Right.
far
Well,
as their
it was
creation and existence.
it was my initial supposition that what all comets and asteroids are broken up terrestrial planets.
Exactly.
Yeah.
And one is highly electrically charged and the other one is not.
Right. I wonder what like a astrophysicist, how they explain this ion tail from planet Mercury.
Because they certainly can't claim that it's, an icy body that's vaporizing. I mean, it's Mercury. It's close to the sun. I mean,
Yeah,
come
it's
on.
pretty warm there.
We know it's not an icy body. So, like,
Venus is so
wow.
hot that you can't land a ship there because as it goes in the atmosphere, it eventually melts and malfunctions.
Well, right. Even the probes that Russia sent to Venus, right? They only survived for a limited period of time
Yeah, you
because
got
it's
a
so
very small
hot.
window. Yeah.
I mean, and they had to specially build them to be able to endure that environment. Wow. That's awesome.
Yeah, it's electric.
Wow. Right. So okay, this also gives me some perspective too about how charged a comet really is, right? It's like it really makes it very clear that a comet is extremely charged. And that is also the reason for its movement through space, right? It's being pulled somewhere, essentially.
Yeah, and I mean, some comet tails, ion tails, can be millions of miles long.
Yeah. Yeah. So compared to a comet, our planetary bodies are clearly not as charged, but they're still charged.
Yeah.
And obviously planets are very stable in that respect. We keep coming back to the metaphor of the solar system being somewhat like an atom, right? That the planets are like the electrons, and all things seek stability, and so the orbital shells of an electron and the orbits of planets will seek stability, and so there's a reason why they are where they are currently. But if you throw something into the mix and you change that, like, so for example, when you have an atom that interacts with another atom and becomes a compound, then things change. The positions of those electrons change. And so it stands to reason that can also happen within our solar system, which is what we've been hypothesizing for quite some time.
Right. And would be what happened in the accounts of Immanuel Velikovsky.
Yeah. Yep.
All right, let's jump into the Younger Dryas catastrophe, shall we?
Mm-hmm.
Now, this has been a favorite topic of ours for years. It's been a favorite topic of mine since I first came across the Younger Dryas impact hypothesis. Then I dove into the Carolina Bays and found the work of Antonio Zamora and then the Comet Research Group.
Mm-hmm.
So if you guys don't know about the Comet Research Group, you just go to cometresearchgroup.org. And what they have here is a list of all the scientific publications with evidence for a Younger Dryas catastrophe. Now, a good rehash of that is a paper. I don't know when it came out. Yeah, 2011 paper. The Younger Dryas impact hypothesis, a requiem. So for those that don't know, the Younger Dryas impact hypothesis is a recent theory that suggests that a cometary or meteoric body or bodies hit and or exploded over North America around 12,900 years ago, causing the Younger Dryas climate episode, the extinction of Pleistocene megafauna, the demise of the Clovis archaeological suite, and a range of other effects, including black mats. It gained widespread attention in 2007, and since then, the Comet Research Group has been attacked by mainstream science as well as mainstream media.
Mm-hmm.
And they're back with a new publication. Evidence of a 12,800-year-old shallow airburst depression in Louisiana with large deposits of shocked quartz and melted materials. Now, based on all the research and all the papers we've looked at, you know, at this point, I would think that mainstream science would start to be leaning towards this theory.
They have to. There's so much evidence, and this just adds to it adds to the evidence and points to the same theory that seems to make the most sense.
Right. Well, the people who disagree with this are the ones that are clutching their pearls and hanging on to the hypothesis that the Clovis culture caused the mass extinction.
God, that's so stupid. What? Why? I mean, okay. I mean, I know, you know, I've said this over and over again. Surely, when you're clinging to your career and it's under threat because of a better theory than yours, there's going to be a tendency to hang on. But why is there this deep desire to continue to blame human beings for anything catastrophic that happens on Earth? It's so strange. It's like some deep psychological self-hatred or something. It's very bizarre.
Right. And it's estimated there are millions of these migratory animals migrating around North America, millions of millions. And there's 5 different species of elephant alone in North America.
Mm-hmm.
So how many Clovis people do you need to hunt all of these animals to extinction?
Well, that's the other very obvious problem, is that the sheer magnitude of the number of megafaunal animals that went away requires huge forces, and human beings, once again, very likely don't have that capability, especially at that time. You know, if we had an industrial society that was working on wiping out the megafauna in all parts of North America at the same time, okay, sure. Yeah, I'm sure we could do it. But I mean, this is ridiculous. Like, which is more likely to be the case? It's a very simple question.
Yeah, I agree. And just to make sure you're up to speed, I'm over here at the Comet Research Group. You can see all of the papers on the Younger Dryas impact hypothesis that were published exclusively in PNAS right here. See how I'm going through them all?
Mm-hmm.
So that is quite a lot of peer-reviewed papers in the major literature right there.
Yeah.
Plus, there is over 100 other publications if you come down here.
Yeah.
Look at this. This all supports impact.
Yep.
Still scrolling. And there's very few against impact, maybe a dozen. So these are the butthurt people.
Yeah.
But most of them support impact. In fact, about 5-6 times as many.
Yeah. Well, it's really quite obviously the only thing that makes sense. And I want to point out too that this isn't a single impact, right? Like, we're pretty sure there was an impact on the Laurentide ice sheet that created smaller pieces of things that then kind of bounced and created the Carolina Bays, right? This is obviously evidence of an airburst depression, which is essentially an impact in Louisiana. So there's something big happening here. Like, we've hypothesized this is, you know, debris from a comet that struck Earth.
There's a lot of debris. I mean, we've got the paper in the Atacama Desert. So these airbursts are happening all across the world at this time.
Right. But
the major body or bodies hit the center of the ice sheet.
Yeah.
And so those biggest so there's hundreds of chunks, the objects coming in, breaking up, the largest pieces are headed to the ice sheet. There's fragments of it that are hitting the Atacama Desert. Well, they're actually exploding right above the surface in a plasma discharge.
Right. We're still calling that an impact. Yeah.
Yeah. This is going to be a shallow airburst depression, different than Tunguska, which is a high altitude explosion.
Right.
So this one came much closer to the surface and discharged.
Which, you know, which may speak to, again, to the idea of, you know, a very large object or several large objects hitting the Laurentide ice sheet. Perhaps that explains why the secondary pieces that, you know, would sort of break off from that would be low altitude.
No, the pieces that came off the ice sheet were ice. They were ice bolides. So it fragmented the ice sheet, and then the projectiles that formed the Carolina Bays were not rocks, they were ice, and they melted afterwards.
And they would have to be rocks simply because the evidence, let's say, in this basin in Louisiana shows lots of shocked quartz and stuff like that.
Well, that's the sand that's right there below
The
the
stuff that's
airburst.
there, right? So,
Melting.
right.
Yeah.
So then my question is can one of those ice bolides create an airburst like this?
No, that's why this doesn't look anything like a Carolina Bay. So this had to
Okay.
actually be a part of the comet.
Right. Okay. So this is smaller pieces from the comet. Got it.
Yeah. The Carolina Bays would be the ice that sprayed out, that went to space and re-entered and hit the East Coast.
Mm-hmm.
And based on that, you can make the exact trajectory of this object coming in.
Sure.
And so I'd like to do that in a show, look at the trajectory of the object coming in from the Younger Dryas and then match it with the torids, with the known bolides like the Chelyabinsk bolide. Do they have the same trajectory?
Right.
That would be interesting. Now, this paper is fascinating because the whole idea of this guy, it's this guy who has a farm almost 100 years ago. He finds his pond with a rim around it on his property, and he thinks it's an impact.
Mm-hmm.
And then later on, his son takes over the research, and he starts to send some samples around to people that are with the Comet Research Group. And over a very long period of time, we get this very detailed paper. Now, did you have time to take a look at the paper?
Only scanned it a bit.
Yeah, it's very similar to any of the work of Firestein or any of the other authors.
Firestone.
They use almost everything available at their fingertips to do the research.
Mm-hmm. I mean, it's extremely thorough, right? Yeah. I mean, they look at the evidence from different angles, and like you said, use everything they have.
Yeah, so let me read the abstract, and it'll give you an idea of what's going on. We report on evidence of a likely low-altitude cosmic airburst near Perkins, Louisiana, associated with semi-consolidated deposits containing abundant shocked quartz, a classic impact indicator, along with spherules, melt glass, and microbreccia. Analytical techniques employed on the materials were optical microscopy, the universal stage, electron microscopy, SEM, TEM, and STEM, as well as cathodoluminescence, laser ablation, neutron activation, radiometric dating. And these analysis reveal that the deposits exhibit morphological and compositional similarities to known impact proxies.
Mm-hmm.
So they used radiocarbon dating as well as argon-argon analysis to constrain the likely age of deposition to between 30,000 and 10,000 years, with a concentration of dates clustering at 12,800 years before present, specifically 12,835 to 12,735. This coincides with the range of the Younger Dryas boundary. The spherules and melt glass abundances, along with the evidence of high temperature mineral transformations, are consistent with the effects of high energy airburst or impact. Now, what I found is that the temperatures discovered here in the petrography are astounding.
Mm.
So it either has to be an actual impact or some kind of super bolt of lightning type thing.
Mm-hmm. Mm-hmm. You know, one thing they don't mention in the abstract too is that they found magnetic anomalies in this crater
in the pond.
Well. Yeah, especially on the what they call the wings, which I guess are the outer sections. So that's significant as well, right? Because it obviously indicates that there's a lot of ferromagnetic material there that wouldn't normally be there.
Now, shocked quartz is a great impact indicator. Mm-hmm. Because what you have is an innocent little sand grain, an amorphous quartz grain. You know, it's a lot of SiO2s all stuck together, but it's a nice little clear little grain that's sitting there when this event happens. And what happens is the grain cracks open from the shock. And because of the temperature, it melts the cracks and fuses again.
Mm-hmm.
And you can see it in using microscopy. And it can be nothing other than what I just told you. It can't happen any other way. It has to be some instantaneous high temperature shock from lightning or an object, plasma discharge exploding right above the surface.
Both of which involve high amounts of energy, right? Which is what allows.
And the third way is when an object actually hits the Earth, and it's the impact that causes the high temperature. So it's right around the impact zone.
Yeah.
Now, they also have archaeological evidence. They've got two types of archaeological evidence above this supposed Younger Dryas boundary in one of the cores. And so they've got more modern woodland arrowheads at the very top. And then close to the boundary, they have 10,000-year-old or so-ish, like a Folsom point, an archaic point right above this zone. So that's another layer of evidence that their dating is probably pretty accurate. But the host of markers that they find here, and here's a really good shot of the crater. And dual-lobed craters, are those a thing? That's the first question that comes to mind.
Well, and then that makes me wonder about the trajectory as well, right? Like how much of that shape was caused by the trajectory. Well, I can't say that word today, apparently.
Right. And so the reason it's shaped like this is because it's an airburst.
Yeah.
So it's not hitting the ground.
Yeah.
So based on the way this looks, the object was coming from the bottom right. And because the most of the blast is going to be moving forward with the object as it's moving forward, but there's also going to be a blast on the backside. And I think that forms the back left lobe. Because airbursts are not going to be symmetrical. You know what I'm saying?
Yeah.
Yeah. They're going to just go boom, and it's going to be big on one side or not.
Well, so and it'll depend to some degree as well on what material is on the ground and how easily it can move.
Exactly.
Yeah.
So I just find it all very fascinating. The whole lead up, it took decades for this paper to be written, essentially. And it immediately got attacked.
Of course.
And at the same time, a new paper came out about the Carolina Bays saying they cannot be impact structures.
What?
They have to be, they have to be natural.
Based on what?
An old idea in the turn of the century that some geologists came up with, that it's some type of pond and the wind blows around it and it forms the rim. The only problem is these are all exactly shaped the same. Millions of them exactly shaped the same. The odds of that being something naturally occurring is 0. Right? It has to all be happening at the same time with the same things to form all of the same things. Yeah.
It's so strange to have a bias against the idea of something impacting Earth. Right? It's not like it's not known that this happens sometimes. Again, something as recent as Tunguska being an example. It's so strange. I mean, and it's embarrassing too, right? That your bias is so strong that you will go to the ends of the earth to ignore very obvious evidence and pull in some other BS theory that doesn't really make sense.
Right. And so here's more of the evidence. You got the microspherules. And so similar structures formed during arc welding as these.
Yeah.
And more. These are aluminum silica-rich spherules under SEM microscopy. And then you got the multi-layered spherules, almost like gobstoppers. More spherules. These are carbon spherules and glass-like carbon.
Mm-hmm. You look just like marbles.
And then look at this. This looks like lava, for goodness sakes. This is some
Yeah.
of the melt glass.
Yeah. Yeah.
Slide G looks like slag from a foundry.
Yeah.
And there's more melt glass here. So this is the actual trench that was dug on the east side of the lake. More melt glass from that trench. These look like the sand in some sand area there. It just all melted together, fused.
Mm-hmm. Mm-hmm.
But the other melt glass was much higher temperature.
Mm-hmm.
The melting points of the minerals observed at Perkins are astonishing. Look at this.
Mm-hmm.
2265 C.
Yeah.
So something happened here at very high temperature. The petrography reveals it. So these are minerals in thin section. Thermally warped glass-filled shocked quartz. So you could see the dark areas, the maroon areas are the remelted fractures in each of the grains. That makes sense, right?
Yep.
Yeah. And so thorough.
Yeah, extremely thorough. I did notice that, because I did at least heavily browse this paper.
And guess what the biggest complaint by people who don't believe in the Younger Drive's impact hypothesis is that the Comet Research Group published this paper in their own journal.
I mean, there's a reason. Well, there's two reasons, surely, why the Comet Research Group was so thorough. A, because it's good science, and B, because this is how you create an airtight theory. You make it abundantly obvious. And then the only thing that a detractor has at their disposal to argue with you is to say, oh, well, it's got to be biased because they published it in their own journal. It's like, how about you look at the actual evidence and evaluate
and the
it on
other
that
12
basis?
papers they have in PNAS already.
Well, there's that too. And
the reason they published it in their own journal is because they recently started a journal on comets and impacts.
Right.
Because there wasn't one that existed.
Right. Right. Well, and sometimes, sometimes when you're working on a theory that is, often detracted against, you sometimes run into a problem with getting journals to print your paper, because if those journals are also biased against your theory, then they're going to tend to not want to publish it. And so sometimes it becomes necessary to create your own journal just to get it out there.
Yeah. And so this is pretty damning evidence here. You could see that each of these lines represents a sample. Each of the colored lines is a sample, and you can see them below there.
Mm-hmm. The
gray line represents, so this graph represents terrestrial spherules versus extraterrestrial, okay?
Mm-hmm. Mm-hmm.
And the argument that everyone has against these guys is that all of their spherules are terrestrial and they're just misrepresenting them.
But why are they in the condition that they are in? Why are they?
And look at the graph. All of the samples have the exact same curve as extraterrestrial spherules,
right?
Not crustal.
Right.
So there isn't even any crustal spherules that they're sampling.
Right.
They're all extraterrestrial.
Right. But even if they weren't, right, that you find things like shocked quartz and melt glass, and there's no volcano there. Like, how did they get into that form if there was not an impact, right? Because this does happen when you have impacts. It changes the form of the material, the terrestrial materials as well.
And how was it 3,000 degrees on the surface there?
Right. It's so lame and ridiculous to try to argue against this, and that your biggest complaint is that they published it in their own journal. Like, that is so lame.
Yeah.
It's embarrassing.
Yeah, I think this is a slam dunk.
Yeah, absolutely. No question. And, again, this brings us back again and again and again to Göbekli Tepe, and the archaeoastronomy analysis by Sitricus and who's the other guy?
Sweatman.
Right? Where
Yeah.
they postulate that what was one of the things that was being recorded on Pillar 43 was something coming out of the sky that would be match up with the Taurid meteor stream. You know, it's like this evidence keeps piling up again and again and again that the comet predecessor to Comet Encke at some point broke up and caused impacts on Earth, and and the time frame lines up, we think, with the Younger Dryas impact, the Younger Dryas event, I should say. And then the resulting climactic changes were enormous.
Right, and they were recording them in their encyclopedia.
Right. And why on earth would you not want to preserve that information to warn future generations that this is a thing that can happen? You know, and maybe it's something that can happen again or can happen repeatedly or whatever the case may be. Like, if you're a human being on Earth, like, it only makes sense that one of your primary concerns, if you're trying to understand your existence and your place in the world, whatever your conception of that may be at the time, would be to understand the heavens and what's going on there and how that impacts us on Earth. It only makes sense that you would record that information in a permanent structure like Göbekli Tepe and then later intentionally bury it to preserve it.
Yeah. So they also think that on some of the pillars, including Pillar 43, all of the symbology, like the V's and the snakes and the hashes, appear to be early Vedic vocabulary.
Oh, that's interesting.
Yeah.
Where did you see that?
Let me pull it up here.
I mean, that's interesting too, like on the level of linguistics, right? Because there's plenty of evidence that even all of the European languages really have an origin in that part of the world, in Asia.
Yeah.
Yeah.
I thought I shared it on X, but I saw it on X and I didn't share it because I'm dumb.
It's a lot of information to keep track of in this day and age.
Yeah, I'm trying to put the right words in here. Of course not. We were just talking about this, which I can share. So
Yeah.
in this, can you hear me?
Yeah.
In this interpretation, this is the North Celestial Pole at 14,800 BCE. That's kind of interesting.
Mm-hmm.
Precession
This analysis is actually from a different paper than Sweatman and Sitricus, but it's similar.
Yeah.
Yeah.
And that date coincides with the Bowling-Allerod warming.
Right. Right.
That's interesting.
That is very interesting.
So much we don't know.
Yeah.
But what we do know is that large objects hit Earth all the time.
Yeah.
And sometimes it's very catastrophic. In fact, the most recent mass extinction and catastrophe is so recent, it's not even considered geologic history, right? It's considered the Paleolithic. That's humanity's time.
Right.
So they even happen while we're here.
Of course. And as it turns out, the first catastrophe that we know of in that Paleolithic period is this. And it was recorded by human beings because it was extremely significant.
And we were highly intellectual, and we watched the heavens, and Göbekli Tepe is proof of all of that.
Yeah. This is, I really feel like I get chills every time I think about Göbekli Tepe these days, because it really is one of the most important archaeological discoveries of all time.
Right.
You know, and you know, you and I have postulated that perhaps the whole structure is documentation of people's observations of the heavens and their knowledge of what was going on in our solar system and beyond. And we don't know that yet, but how well pillar 43, which is, one pillar out of, I don't even know how many, right? Because only something like 5% of Göbekli Tepe has even been uncovered. But just that this one pillar, there's pretty good evidence that it points to documentation of a significant astrological event, that tells you that the rest of the monument must be just chock full of information. If only we could translate it.
Right. And the fact that there are depictions of modern constellations 13,000 years ago with the same meaning, that should send chills down your spine.
Well, yeah, and we've talked about this before. I mean, this is an interesting kind of conundrum, right? Because you can argue that constellations are kind of like clouds. Everybody looks at a particular cloud and will have a slightly different interpretation. However, you can argue that there's good reason why certain constellations, that we would group certain stars together and that would persist, because the information is being handed down from generation to generation. So, once we recognize Scorpio, the scorpion, and then we tell our children about that all of the subsequent generations see it a similar way. Now, granted, in the analysis by Sweatman and Sitricus, they are acknowledging asterisms that we currently do not recognize. So, that raises some other questions as well, that would represent different animals that are not in our zodiac or our constellation encyclopedia.
Right. And I think that this is very revealing. Prior to this catastrophe, we've got the megalithic builders, the giant, unexplainable, perfectly interlocked, whoever's building them, they had no language. They had very few symbols. They did have the snake. There are some snakes in Peru that are worked into the masonry. They're not like carvings like this. They're worked into the masonry, and you have to step back and actually see the symbols. But after this catastrophe, all of a sudden, you've got all of this information being written down. This is the beginning of language, I think, because prior to this, everything was handed down through verbally, through stories, through, you teach your children. And then this event occurs and humanity realizes this is not going to work out. What if we all die? Our stories will never live on. We've got to write all this information down.
Well, because earlier you said, there was no language. Did you mean there was no written language?
Written language, yeah.
Verbal?
It was all oral.
Yeah. So we're making the distinction between verbal and written. Because
humanity must have realized we can't continue to do it this way. And that's when it's this time when all the petroglyphs and pictographs begin in North America. The oldest petroglyphs and pictographs date 12,000 years ago.
Right. Well, but don't forget as well, though, that we have cave paintings in Lascaux that are 40,000 years old that would seem to depict the Pleiades.
So this all began. This knowledge, we've been very smart, and this knowledge began a very, very long time ago.
Well, and what's interesting too is that, and to me, this intersects with the idea of the Yuga cycle, right? Well, if we're the most psychic and the most intelligent, and we have the best morals in the Golden Age and the worst ones in the Bronze Age, and as we come down the Yuga cycle, we sort of get dumber and dumber in all of those respects. It lines up as well with the verbal language piece, because the symbols, the drawings and the pictographs and all of that, they're universal. Anybody can understand them. You don't need to translate anything, right? But when you start getting into multiple verbal and written languages, that's the Tower of Babel. That's when all of our communication breaks up into all of these specific pieces, and it becomes harder and harder for us to communicate with each other. So while there's this plethora of languages that seems like it's some indication of intelligence or something, in reality, it separates us and it makes it harder for us to communicate and understand things. Your mic is off.
Absolutely. Yeah. So much more to know and so much more to study.
Yeah. Indeed.
That was a great show. Thank you all for joining us here exclusively on Rumble for the live stream of Cosmic Catastrophe. This is always replayed Wednesdays at 8 p.m. over on YouTube. And the reason we are exclusive on Rumble is because they are king and they don't censor. And so if we do put it up on YouTube and they don't like what we have to say, we'll be demonetized again and all that nightmare.
And we prefer to support free speech. So find us on Rumble, 8 p.m. Mountain Time, Saturdays. And then if you care to watch the premiere on YouTube, Wednesdays, what time?
8 p.m.
8 p.m.
Maybe. We'll
Maybe.
make it a mystery.
If you're lucky.
See you next week.
Take care.